So let's talk about, it's recording, right? Okay. Let's talk about objects. And I think I'm going to dispense with what's going on with the, in the handout right at the moment. And I'm going to try to do something that's a little simpler. Just because it's easy enough to create a class. And I'll do something that's really very simple. I'll begin by saving this as test.py. And why don't I, oh, I see. Why don't I create a class? We'll call it myString. I'm going to put it into a module called myString, but in fact, I'm going to do it in the same file. All right. Now, we've looked at methods before, right? And we've looked at objects and methods. So if we create, let's say, this string, and it's a string, and we wanted to uppercase it, we would just say new string equals this string dot upper, right? And if we printed new string, we would see hello world, right? Makes sense, right? We're creating a new object, what we call constructing the object. All of a sudden my VI is, oh, there we go. We're constructing the new object, and we could maybe make this even a little more comprehensible by putting the stir around it. We're calling a method on the object, and we're getting back a return value. Look at that constructor, stir. That's the constructor, right? And it's a special call to a built-in function that creates a new and returns a new string. Now what we want to do is replace this with our own code. In other words, we can do something that's very similar to a string function and create a method that's very similar to upper. The point of writing classes is to write our own objects that have their own attributes and do specific things. Now, a lot of times I begin this session by trying to talk about why we need objects, and I'm going to dispense with that as well. Basically, it's to deal with complexity. It was invented in order to deal with complexity, and it was a revolution in computing. Python embraces objects to the point where everything's an object, right? Everything acts like an object. Everything that you have, right? Your strings, your lists, your tuples, your functions, your modules, they're all objects. They all have attributes. We're going to create our own and design our own objects that act the same way. They act the exact same way. And our string is going to look very similar to this. This is what our own code will do, or will look like. It's going to look like this. My new string equals, what should we call our method? We're going to call something that does, let's say, we're going to call it our own string.
So this is a new line of code you're writing now?
This is a new line of code.
Okay.
And we're going to say my new string, let's say my new string. Let's say my string equals, and my new string equals my string dot upper. Okay? Print my new string. Yeah.
Okay, yeah,
You know, you guys are such perfectionists, and I'm just like I'm getting a little weary of your perfectionism. Okay. So, do we have to import? Do we have to import? No, we're going to create the class ourselves. Okay, now compare these two, right? One is creating string, right? Obviously, we don't need the stir, right, at the top of the first line there. We don't need stir, really. But I'm just trying to show that they're going to be very similar. We'll always need to name our class when we're creating our own objects of our own class, right? Perl, of course, has the built-in, which means that we don't have to say stir unless we're explicitly converting from something else. So we can just say hello world. But that's just a syntax help, right? That's just a syntax assistance. I'm sorry. I'm talking even louder and more stridently for the recording. Really? Is the camera on me? So we're constructing a new object, and what are we doing here constructing a new object, right? We're passing some value to our class, getting back a new our own string object. Then we're taking that object and we're calling upper, the same method that we're just going to create ourselves. We'll create our own upper method. And that returns a new string which we can then print. So it's going to behave just like a string would. Doesn't mean we can call lower on it, right? Or any of the other methods. We're just going to implement the upper method in our own class. So we're going to recreate that same functionality. Yeah, just.
Is the first line of code with our own string correct? Because that's not being defined anymore, is it?
Right, we're going to define it.
Okay, sorry, I was confused.
Yeah, sure. Yeah, we haven't defined it yet. You're right. Yeah, we haven't defined it yet. Good eye. We haven't defined it yet. We're going to create the class now to implement it so that it behaves in the same way. But you can see now that our own custom classes are really just our own custom sort of objects that have their own behavior, but that act a lot like, they don't have to act like strings at all, right? They can do whatever they want, right? Could be a database interface module that maybe you like to insert a line of code into the database, and you know it's going to insert certain fields, right? So you create a special insert class, right, where all you do is create a new object and then just say .insert and put in the fields, and it just does all the work. All the work is encapsulated inside the class that you created that has all the code that connects to the database and makes the SQL query and everything else. But you don't want to repeat all that stuff. Instead, you want to create a class that does all that, so that the interface is very simple. My DB insert dot insert, and then the fields that need to go, and you don't need to. You've now covered over in the very simple interface. You've covered over all of the inner workings of that class. So that's the justification for a class. But it's more than that, because you can create multiple objects of that class that do different things. I'll give you some other examples as well. My favorite is the ATM. That's my favorite sort of real-world sort of approximation of what an object does. What does an ATM do? It gives you stuff, right? It gives you cash, lets you know your balance. But it's not really your ATM until you put the card in, right? Before you put the card in, it's just basically saying, I'm an ATM, but I'm not really anyone's ATM, and I'm not really doing anything yet. Once you put the card in, it becomes your ATM. Putting the card in is sort of like creating a new ATM object. And then you can just say things like get balance. So get balance, it's not going to get anyone's balance, it's going to get your balance. And if you say, withdraw money, the same thing. It's all going to come from your account, your stuff. And that's the idea of instantiating an object. You can say our own string hello world, and you can also say our own string this, that, and the other thing, whatever you'd like to put into the value. Now, when we say myString.upper, it's going to uppercase the value that we gave it. So it holds its own data, right? And that's really the definition I made you regurgitate the first session, right? It's a unit of data that has access to common functionality. Common functionality meaning upper, the unit of data being this particular data. So it's more than just creating something that does something great, because you can write a function that will do that, right? But classes allow you to create multiple objects that all do the same sort of thing, but they work with different data. And we'll maybe talk about other examples of that as well. But let me show you the guts of it. Let me show you the guts of creating your own class that would do something like this. That would accept some data, hold on to it, and let you do functionality with it. Let's do that. Any questions? Any other questions about this? All right, I'm going to show you the class. So, class, our own string, object, init, starter string, or yeah, string value. Self dot. There's going to be a lot here, so we're going to have to break it apart later. Self dot value equals string value. Definite. Def upper. Self return self dot value dot upper. Obviously, we're calling the upper method from within our class, but no matter. We could have done it ourselves. We could have referred to the ASCII table and, right? changed each one using the chur and ord functions if we wanted to. The point is not so much to be creating some very practical object, but instead to show you how we implement a class and what we're actually doing when we do that. So this is it. This should work. We should actually try to run it. We should see, I guess we should see hello world twice if we run this. I hope it works. Let's see. Yay! Okay, you tried it? Nice. Okay. All right, so let's talk about what this class is actually doing. And let's talk about what self is. Don't worry about the object just yet. Anytime we instantiate a class, we like to inherit from object. We'll talk about that later. What we want to talk about is how we're actually able to create an object that has its own data. We're creating an object that has its own data. Because when we call myString.upper, it has to know that we're saying take hello world and uppercase it, right? We're not referring to hello world here anywhere, right? We sort of stored it in the object using this special syntax. We created a new object that has hello world in it. And the way we did that had to do with the self object. This is class hour string. This is the class definition. And you can imagine now that since we're working with a string, we could implement whatever we want. We could implement lower. We could implement find and all the other methods. We could create our own string methods. Maybe we want to create a string that acts like a string, it works like a string, but it does other stuff too, right? I don't know. What else would you want to do with a string? It does some special kind of things. Like when you call split with no argument, it splits on a colon by default. Whatever you want. Some special thing you might want to happen. Maybe every time I don't know. I can't think of anything at the moment what you might want to do special with a string. But the point is we have full control over this. So let's look at the definition and how it actually works. The key is self. The key to the object storing information is self. Self is the way we refer to the particular object. And I'm going to show you that it doesn't matter. Self can be anything, really. And I'm going to do that by creating a second string. My string 2 equals another our own string. And this is going to be goodbye, cruel world. And then here we're going to say, let's just print it directly. Print my string 2 dot upper, right? And we're going to see it again, right? We're going to see the same thing. Goodbye. You can take my word for it. I don't have to run it. In other words, my string 2 is another my string object, or another our own string object. And it has its own data. Calling upper on it refers back to the data. So let's talk about self and why we call it self. We could also have called it this, although I don't think self is a keyword. I don't think it is.
You use anything.
You use anything, yeah. I can tell you that you should always use self because it's just de rigueur. It's another one of these traditions. We always say self in Python. In Java they use this, right? They use this in JavaScript too. Yeah. So we use self. Self means the current object, the one that we're working with. Now let's read this code and follow through with it. And normally I don't introduce init right away, but I wanted to show you kind of a practical example of an object that does something similar to something we're already familiar with. When we call our arm string, we're referring to the class, right? But we're not just referring to the class itself. What are we doing with the parentheses? What does that mean when we put parentheses after something? It's a call. It's a call of some sort. And when we put parentheses after the name of the class, we're calling the constructor. It means we're asking for a new class object, or a new object of the class. A new, what we call an instance of the class, an object of the class. We may as well just stick with object. Sometimes you'll see in the documentation, you'll see instance. It just means an example of, or an object of. It means a particular instance of this class. It's an our own string object. That's what we call it, an our own string object, or an our own string instance. You can say that too. Anyway, It's an object that identifies as an arrow on the string. It says, I am an arrow on the string. I'm calling it arrow on the string, meaning it's our custom string. We usually call it custom string. But anyway, it's particular. Now, calling the class name with the parentheses creates a new one, right? It also calls a init. I'm going to show you the most basic class we could have before we go any further. This is what I usually do, but I think it confuses people. Class, small class. Pass. X equals small class. Y equals small class. Call it tiny class. All right, remember what pass is for? Pass says there's nothing in this block, right? But we need something in there with an indent, right? So that Python interpreter doesn't get confused. This is a class that's about the smallest. It is the smallest class you possibly have. It has nothing in it. And yet we can create new objects of the class. We can't do anything with them really. We could print them. See what we get. Small class instance. You see, we did create two instances, right? We created two small class instances. All we did was take the class name, put parentheses after it. That makes it into, in the definition, it means the definition, right? But in the call, new constructor, we've created two new small class instances. This is about the smallest you could get. Now, what normally happens when we have the class name with parentheses is we construct a new object, and it'll try to call init. Init stands for initialize, and it's one of these keywords in computer science that simply means make it, initialize, like give the initial values to. Init, you'll see that often. Init, it means initialize. So they gave it a name. It's a specific designated name. You can't change the name. Whenever you create a new object of the class through the constructor, it's going to call init. So let me get rid of this and go back to our original example. Init. So when we call our own string with parentheses, we're constructing a new object. The first thing it does is it calls init. Now we have a first argument self. Now notice, how many arguments we're calling our own string with? One argument, right? One string. How many arguments in init? Two. It's a mismatch. You see that? Check out upper. How many arguments are we calling upper with? 0. How many in upper? Up here. 1. Same mismatch. There seems to be one more argument in each of these functions, what we call methods. There's an extra argument, right? We call it with 1, it takes 2. We call it with 0, it takes 1. How did that work? It's always going to be that way. Well, you see the self, right? Self is common to both of them, and it comes first. This is something you just have to understand. Any method that's called always begins with argument self, unless it's a very special method, static method, and class method. We're not going to talk about those right away. Any instance method, an instance method that is a method designed to work on an instance or the initialization of an instance, right, begins with self as a default first argument. What is this self? What is self? Why does it suddenly just appear? Self is the object. This is the guts of our own string. Do you see what we're doing here? We recognize the syntax with self. Object.attribute, right? Object.attribute. An object, like self, this is not going to be true of your other objects, right? It's not true of a string object. You can't just create this. We're arbitrarily creating a new attribute of self. We could have called it anything. We happen to want to call it value. We could call it val. We could call it whatever we want. we're setting a new attribute in this object. And we're assigning the value of the string that was passed in the constructor to the attribute. This is how we store data in an object, right? Remember the definition I gave you at the beginning? An object is a unit of data with associated functionality. The associated functionality is the methods, but the unit of data, that's the particular data that belongs to this particular object. That's why in Java they use the word this, meaning this object, this particular object. When we say myString.upper, well, we're calling upper on this object, right? So this object becomes self. MyString is self. And actually, in the init, I should make it a little more explicit. Return self. Obviously, wasn't needed, but self is the object. Self is the object. So when we're initializing the object, self just gets created out of nowhere, right? It didn't come from the call, right? Because we didn't pass 2 arguments. Hello world becomes string value, right? String value becomes associated with hello world. Self is a built-in object. I mean, it's an object that just appears out of nowhere. That's the one thing I want you to get. Self just appears out of nowhere. Python creates it for us. And it becomes the object that we're going to work with. When we want to store this value, which we're clearly initializing the value to the object, we do that by creating a new attribute and assigning the value to it. Now we're doing this manually. We're doing it ourselves, right? This is not default behavior. We've decided to do it. We could have added it to a new list if we wanted to. I mean, let me show you how arbitrary it is. Self.value equals a list in which the first element is string value. And when we return it, we'll just say string value 0. It's the same thing. Now self.value is a list, and this will work. Unless we made a mistake. Oh, because you don't return it. I forget. I'm sorry. I forget. We don't return it. I kind of want to show that it's being returned, but it gets returned by default. So it worked. And we had changed it so that now self.value is not a string, it's actually a list. And then we just treated it properly. I'm just showing that whatever happens here happens to us manually. Now we do want the attribute to be a string, so there's no need to turn it into a list, although it's certainly our option. And in your homework, I'm going to ask you to do something similar to this. Okay, so let's look at init again. Init, we're creating brand new self, which just gets created out of the ether, and we assign to a new attribute the value of the string that was passed, hello world. If this constructor had nothing in it, we wouldn't see a second argument. We would see self though. All right, so that's init, right? It gets called automatically when we call the constructor, and the constructor is always named after the class. So it's class name with parentheses. This passes up hello world. Self gets created automatically. We are manually assigning, manually meaning explicitly in our code, assigning the string value to a new attribute of self.value. And if we wanted, we could create another attribute of self.value. We could say self.num equals 1 if we wanted to. Create as many attributes as you'd like. This object is almost like it's like a walking dictionary almost, right? Except that we're using attributes instead of, indices. All right. Now, second. So questions about this? Questions about init? Questions about what we're doing with init?
So init is only constructor based for the Python class.
In
Can I use something like others? Like I define the same method as the class name. Would it be the same thing?
You mean if you created your own function called our own string?
Yeah.
It would probably get, well, I think what would happen is if you put it after the class, it would overwrite the class.
If I put it inside the class.
Inside the class. You want to say this?
Yeah.
You can you would like that several constructors.
No,
What is?
I'm just curious.
Or you just want to know if you name it the same thing?
Yeah.
Well, this is part of the class
There's gonna be
definition.
Uh,
This is part of the
our
class.
own
Wait,
string
hold on.
dot
This is
our
part of the
own.
class definition. So when you call it outside, it's not going to find it here. It's going to find it up here, right?
Yeah,
It's an attribute of the class, so you won't be able to find it in there. You'd have to call it maybe directly by saying string.
Okay.
Maybe. What were you going to say, Ed?
No, I thought that his question was that how do I define several different constructors? You know, like in other languages.
Right, like with
Overloaded.
different signature.
Overload.
Right, overloaded. Yeah. That's a good question, and
I don't think Python allows it.
Yeah, I don't think so.
It's a unit.
because if you define a new init, it's just going to overwrite the old init without a doubt. That's actually a really good question. So the question that you inspired was, you know, in other languages they might allow you to call a constructor in a different way.
You can probably have one class within a class.
Like that, without an argument, or with 3 arguments or something, and then it would construct a new object, but it would do it differently. It would call a different function. I'm not sure. Class
You have
within a class.
Class within a class, and then you just what is it called? Inheritance.
Mm-hmm.
Inheritance is not a class within a class.
Well, yeah, but I'm saying if you can only have one initial, init, then
Duck typing. Oh, this is stupid. I don't know if you see this. Whoops, it doesn't help. Here he's saying, look, call it with the same signature, but the type of the argument might be differently. That's not helpful. And that person seemed to be satisfied with it. And the other person says, no, it's not, and you suck, and etc. I don't know if you notice how snippy a lot of these answers get. We have 2 idioms that cover most of the uses of multiple constructors. Duck typing, default values. Oh, you got your default values. There you go. That would do it. Right. Right. It would work that way. You'd have op val equals this, and or whatever equals none, and op val 2 equals none. And now if you call it with different constructors, I mean, if you call it with 3 arguments, it'll behave differently.
Or you can just call whatever and then set values, set different.
Call it with.
Construct a primitive object and then calling several methods.
Yeah, sure. You
Finish
could
the
do that.
construction the way you want.
Right, right. Then you wouldn't have an overloaded. You just have different. Yeah. Right. Yeah. All right. That was good. That was good. Good question. All right. But
Another
yeah,
question.
sure.
For the methods in the class, do I have to include the self with the function?
If it's a method that's designed to work on the object, then yes. If you call it on the object in this way, then you must, because now getting to upper. Let's get to upper. So we had this. Any more questions about init? So getting to upper, we say myString.upper with no arguments, right? And you see self up here. This usage, myString.upper, actually creates a call to this function with the object as the first argument. So if you call it this way, you must capture it here. If you put no self here, you'll have an error. What it'll say is, if you change this so that there's no self, when you say myString.upper, it's going to say takes no arguments, but one was given. In other words, it says, okay, I don't take any arguments. But when you call myString.upper, it actually passes a first argument automatically. This is the other little bit of automagic behavior that we want to talk about. MyString.upper, the call itself, passes MyString as the implicit first argument. Even though you don't see it, it goes up as the first argument. And that's actually MyString itself. MyString is self. MyString2 is self when we make the call. it becomes self. It's the same sort of assignment that we talk about with arguments to functions all the time. And in fact, what it actually does is say, what it's actually doing is calling our own string, my string, our own string, wait a second, our own string dot upper with my string as an argument. That's what it's actually doing. I think that works. Our own string dot upper with my string as an argument. And that's, oh, and then of course we got to go back to having self up here. And this is what makes, this translates to this. So it looks in our own string, the class, for the upper method and finds it. And it passes my string as an argument. That's what this does. But it keeps us from having to name the string. My string knows what it is. It knows it's in our own string. So when we say myString.upper, it's going to look in our own string for the upper method and call it. But it's also going to pass myString as the first argument. So you have to have self. Now, there are examples where you wouldn't have self, but we'll talk about those. That's a little further down the road. So what does upper do? It takes self as an argument, right? Meaning it takes myString as an argument, or it takes myString2 as an argument, and it returns myString.value.upper. In other words, it takes self.value, uppercases it, and returns it. We've got this double sort of attribute thing, because self.value is itself a string, right? So we take that string and call .upper on it. So that's how that works. I feel exhausted. I don't know if you do. And I don't know, well, it probably mostly makes sense, right? For the most part. I hope so. I feel like I should stop this and try to export it or something so that I can make sure to retrieve it. But it means I gotta take a pause. If you don't mind taking a, we can take a short pause. Any other questions about this right now? Are you sure? Oh man. Did it stop recording? Oh, what a drag if it did. Oh, there it is. Excellent. So that was 30 minutes of recording.